Take a second. All right. I think this is all set up. Ready to go. Okay, so as the title for this stream says, I'm going to attempt to try to do spatial joins with the ArcGIS API for JavaScript. So there's a few caveats to this, a few things that you need to know. For one, yes, this works. You can do it, right? It's like a basic GIS thing, right? And I come from an old school ArcMap background and stuff like that. And basically, one of the most basic things you do is you do a spatial join of your data, where you basically take, in this example I'll do, you basically take like a layer of points, a layer of polygons, and you do a join to them where you create like a new layer and a new table, and they're joined spatially. So like a polygon of parcels, for example, might get joined with a point layer of chimneys or pools. Pools is a good one, right? You got a point layer of pools on properties, maybe taken from some sort of raster data that was analyzed or something. You got a layer of parcels, and you want to find out which parcels have pools, right? So do a spatial join on this point data, and you get a new polygon layer of parcels that have an attribute that maybe says pools, or some kind of something that you know that you did the join, right? It's spatially done. There's table joins, and the table join is basically just to join the two tables regardless of geometry. There's no spatial functions really involved with that, right? So if you've ever done that in a desktop, depending on the data set you're working with, those could take a while too. So you can imagine if it's something like that could take a while on a desktop, it's probably going to take a little bit on the web, depending on the data set that you're using. Now, if you're not concerned about data, okay, I'll be straight up with you. If you just care about, I've got a feature layer of polygons, I have a feature layer of points, and I just need to know where they intersect, right? I just need a layer of polygons tell me where those points overlapped. Your best bet and the fastest bet is to just use Geometry Engine and do something like, I think if you create them as maybe multi-points and you merge all the polygons together or something like that. I'm not sure, I have to try it, but you could use something like intersect, right? Creates new geometry through intersection between two geometries. I'm not sure if that works. Intersects would, you would just loop through all the different geometries and do an intersects. I thought there was something in here. No, I was gonna say union, but they have to be the same type, so that's not really gonna work. Unless you've got like, you're working with two polygon layers or something like that, then that might be what you want. Right, so Geometry Engine is definitely like the fastest way to find out if those geometries actually overlap together. The not so fastest way, but like I said, still works, is to go ahead and do something like, if you're working with polygons, I got parcels. Polygons have a method on them called contains, right? And you just pass it a point. Real quick, does this polygon contain this point? All you got to do. So that is what we're going to do over here. So I've got this data set of, I thought they were TRIs, but they're actually called Facility Registry Service Interest. And that's like the first time I've heard that term. Looks like it's basically anything that could be a pollutant source of some sort, right? And there's a lot of them. I'm zoomed in to a decent area. I'm not really zoomed far out because this thing would just take like 5 to 8 minutes to run. I'm going to get a pop-up in the browser telling me this shit takes too long. Do you want to wait? Do you want me to exit? Whatever, right? Because it does take a while. And I have a polygon layer of incorporated cities, right? So basically all I want to know is for these possible pollutant sources, how many of them are in each city, right? So I just need a count. All right, so that's all I'm going to do. So I've got the basics of the map all set up here. I have this function here that's going to create the layer for me after I've done all of the data processing, right? Basically going to go ahead and it's just called create layer. I'm going to load the layer. I'm going to copy. I'm going to create a map for the field infos map. And the reason I do this is so that I can just kind of quickly sort it all. Then I convert that into a set, and that's going to remove any duplicates for me. right? So that's all this really does. This is to get me the fields of the layer. And I don't even think I really need that because realistically, I'm only interested in count. I'm not really interested in any other values. I might want to use that if I do. But then again, this layer, I have to set all the, like the outfields to all for the points, and there's a lot of points, and that's probably going to slow it down even more, so I'm not going to do that. Not interested. So basically, I'm just going to copy the geometry type for the polygon. I pass it the array of features that make up the layer, which is going to be after all my data processing here, so that's my source. And I'll give it a pop-up template just so I can click on it and return that layer. So, okay, so I have this work I'm going to do after view.when, right? It's going to be async because I'm going to do a bunch of asynchronous stuff in here. And I should mention I came up with this idea after talking with Christian Ekenis about this. I have a reputation for doing dumb shit that will work sometimes, but not all the time. So I'm a great sounding board when you think you have a dumb idea. I'm definitely one run by it. So he was kind of thinking about this stuff, and I had kind of thought about it before if it was possible or not. And yeah, I think it is. It's possible. I'm not sure how smart it is, but it's definitely possible. So, okay, let's do this here. I can't figure out my settings, how to make it not refresh or recompile every time I type. I don't care. Let's just go ahead and do it. So what I'm going to do is I'm going to get my layers, right? So I'm going to, I need all of the layer views. So I'm going to do an await. Let's see. Okay, here we go. Promise.all. I'm going to pass this an array and view.when layer view. Camera shaking. And I got a couple layers here. City layer and FRS layer. That's what I'm doing. So let's do city layer and let's do this FRS layer. Okay, there we go. So I'm gonna go ahead and say this here, city layer view, FRS layer view. Okay, so now I got my two layer views because I could do this one of two ways. I could do this based off of just the geometries that are visible on the map, and that's like the fastest way to do it, right? The other way I could do this is try to download all of the features from the service into the browser, manually download them myself, meaning that I'd probably have to deal with pagination in some way. View.when lay view. No, there's not. Sorry. Which means I have to deal with all the pagination stuff, and I don't want to do that. So I'm only interested in getting the features that are in the client because then it'll be fast. Well, relatively fast, right? Okay, so now what I want to do is I want to wait for the view to finish drawing, right? Normally, if I'm only interested in certain layer views, I'd wait for when that layer view updating property is false. But in this case, I care about when the whole thing's done. So I'm going to do an await when false once, if I could spell, view updating. So when all the layer views and stuff are done updating, this will go ahead and work for me. Yeah, there's errors at the bottom. I don't care about the errors at the bottom right now. Do I care about that? I don't think I care about that. No, I don't care about that. You know, this is let's close that. Very disturbing at the moment. So, okay, so we've got that. Next thing I need to query some data. So I'm going to create a query object I'm going to reuse. Because for this query object, I want to make sure I get back all the geometries, right? So return geometry 2. True. Okay. Like I said, I could put outfield star here, but since it's client-side data, it's not going to matter. It's only going to give me back the fields that it needs to draw, which in this case, I don't even think it needs anything more than for the polygons. Looks like it's not colored by anything, so it's only going to be the object ID. I don't care, and I'm sure there's other fields in here that I could use, but I'm not interested in that. And I could probably do like a depending on these types, I can do like a count on all these, get some stats and dump them in here and use that. So I'm just gonna do a count. Let's keep it simple for demonstration purposes, because if I start down that kind of road, things are gonna get carried away. So let's do this now. So const city results is going to be equal to await city layer view dot query features, and pass it the query. Let's go ahead and copy this, paste it. Let's call it FRS layer view and FRS results. How about that? Sound good to everybody? All right. Let me double check something here. And I mean, as I'm doing stuff here, if you've got questions, go ahead and you can ask them during the stream, put them in the comments later on. I'll get to them when I can. I'm not really looking at the chat for the stream though, so I'll check it every now and then if things pop up. So I need a couple things to happen here now. So as I go through the array of features, right? So these points, there's a lot of them. Okay, let's start with this. So first, I need something to hold the features I care about. So this is going to hold the graphics that are going to become part of my new layer that's copying all the spatial join data. I want a temporary, I don't know if it has to be let or not. I can't remember if I need to do this. We're going to go and copy the results from the FRS oh my gosh, results dot features. Okay, so now I've got the point features that are displayed in the map. I need another like temporary array to hold stuff, and you'll see why in a second. And this just kind of speeds up this whole iteration step, doing it this way. And let's just kind of get through and I'll show you what it is I'm trying to accomplish. And I don't know if it's really the best way to do it, but I found it kind of saved a few seconds here. So city results. So I am interested in iterating over every polygon in the on the layer. Every polygon for the city I can see, I want to iterate over. And then what I need to do is I need to iterate over every point on the map with each polygon. And you can see where this kind of gets slowed down now, because every polygon now needs to check, is this point inside? Okay, yes, good. Is this point inside? No, it's not. Okay, good. Is this point inside? Yes, good. This one? No, okay, bad. Right? So I got to do that for each and every polygon. You can see it's kind of it's a big O problem, right? So trying to reduce that complexity. Well, not complexity. I'm trying to reduce the work it needs to do is realistically what I'm trying to do. So let me create a new graphic. Well, I'm going to copy this graphic. I'm going to clone the feature. And, you know, I'm so used to doing these clones everywhere. Every time I work with like graphics and geometries and stuff, I don't know if I really have to anymore. I think that we've made some changes in API where it's not necessary, but, you know, because I'm going to play it safe, I'm going to go and do that. So at this point, I've got my graphic, and I want to add my count. So attributes going to be equal to 0. So I haven't started iterating over yet. Not, oh my gosh, no, not this. Scared me. Okay. All right. So it's 0. And I added this count in here when I created the layer somewhere over here. Oh, I haven't created the layer yet. I'll be creating the layer in a second. When I create the layer, I'm going to go and tell it that I want there to be a count field in here. There we go. That's what I want. Okay, so now I've got a graphic that does a count. So now we're going to iterate over the point features. All right, so in this case, I'm actually going to do a good old-fashioned for loop. I is equal to 0, I less than temp. No, okay, wait. We'll get there in a second. Hold on. So before I do that, I'm going to make temp2 equal to a copy of this one. All right. So I probably could have just done this down here, but it's okay. It's okay. I'm just going to go and do it this way anyway. I probably don't need this here, but you know what? I'm playing it safe. Don't worry about me. I'm thinking in my head, do I need to do this stuff or not? What's this error? What's it telling me? I expect the token. Oh, there we go. Sorry, my bad. Okay, so now I've got a copy of the layer, right? So what I want to do is I want to loop over this. So I'm going to let where I'm at, I equals 0, I less than temp2 dot length, I plus plus, right? So here's my loop. So now I'm going to say is I'm going to go ahead and say that x is equal to temp I, and oh my gosh, what am I doing? Now there's a reason I did it this way, because I want the index I'm currently in as I'm iterating over this loop, right? And some other stuff I need to do here. So I need some if checks here. So first off, if, okay, so let's do this right like this. So if x and, because I might not have something here. So and graphic dot geometry, right? Yeah. If x and graphic dot geometry and x dot geometry. I think that's right. Yes. No. Wait. I need another one. And this is what I want. If so, the graphic is a polygon. I probably should have called them polygons. And if the graphic dot geometry, and I know it's a polygon, so I'm not gonna do a geometry type check. Although if you're in production, you probably should, because that would make this much more useful. Is going to contain x dot geometry. And again, I know that x is a point. Oh, that's long, man. Oh, okay. All right. No errors? Okay, I got an error. Where's my error? Doesn't like this? Oh, that's why. Look at that. Can't type. Okay, I fixed it. So, if I've got a feature here, and if the graphic has geometry and this current feature, the point has geometry, and the polygon graphic contains my point geometry, let's go ahead and do something. So first thing I want to do is I'm going to go ahead and say that the attributes.count is going to get bumped up, right? So there's one point inside the polygon. That works. So now is where I'm trying to reduce the amount of work that I need to do in my array. So now I'm going to say that temp dot splice 1. So I'm going to go ahead and at the index where the point array is contained inside geometry, I'm going to go and remove this point now. That's what this does here. But this is destructive, right? So then I'm just going to finish going over my array, finish doing this thing, and with the temp. And then when I come up over here again to the next polygon, I say that temp2 is equal to the we call it copy of the temp array. That way, as I'm going through, this polygon is going to say, okay, I've already checked all these points. I don't need to check them anymore. Actually, I should probably do this. This will do it better. Let's come over here. Yeah, I'm after. So I do everything, right? Because I'm basically saying that if this polygon has already checked all these points, these polygons don't need to check those points anymore, right? No, that's not right. That's not right. I was right when I set this in here. Or else it would just remove everything. There we go. That's right. So if this polygon contains that point, then remove that point from the other points the other polygon is going to check. There's no reason for this polygon to check these points if they've already been found to be over here, right? So that's going to lessen the workload a little bit that it needs to do. And I'll be honest with you, as you zoom out, it doesn't really matter. It's just a lot of work. I've had this thing sit here for like 5 to 8 minutes when I was really zoomed out doing all of that work. So, okay, so that was like the main thing you need to do. So after I've done that, let's come over here. So where's my, so that closes there. Okay, so now we're going to go ahead and say features dot push the graphic. Okay, so now we're just gonna store that graphic in a features array, and we're gonna save it. Because now what we're gonna do is we're gonna go ahead and create the new layer. So first thing I want to do is I want to do map dot remove many. And I'm going to go ahead and remove the city layer and the FRS layer. All right, so let's get them out of the way because I'm not using them anymore. I'll create my new layer. So I'm going to say that my call it join layer is going to be equal to await. I have to make this an await because that's an async function up there. Create layer, and we're going to pass the city layer because the city layer is the like what I'm kind of basing everything off of. I want to display the polygons on the map. So I'm going to do the city layer. I'm going to pass it the features because those are the source, and then I'm going to pass it empty array. You know, I could do something like this. So here's what I was thinking I could do, and maybe I will. I'll just show you, because what I want to do is I want to pass a new field that's going to get added to this layer along with the polygon layer. It's going to be the count stuff. It's going to have an alias of count capital, and type is going to be integer. And then if you look at my create layer method, where is that? Down here, I think. Here it is. When I pass those extra fields in, it's just going to add those extra fields to the fields for the new layer, right? And this is really only useful if I'm going to do something like in the pop-up or something, or I think, or maybe do some sort of a visualization based on the count, which yeah, I'll leave it in there. It'll be fine. I think that's what I'm going to want to do. So okay. So I've got that. All right, so I've got my layer. Now at this point, I need a renderer. So I'm going to say, I'm going to use the smart mapping. That's a long name here. Bear with me. Oh, color renderer creator. I can just drink of water now. Create continue us renderer. Jeez. Need to come up with some shortcuts for this stuff, man. Or like, you know, maybe some TypeScript IntelliSense would be worth it here. Okay, so now I'm going to have my layer is going to be the join layer. There's some stuff I have to pass to this function so it can do its renderer smart map and magic. Pass it the view. The field I want to do base my renderer on. It's going to be count. And then the theme is going to be above and below. Above and below. Yeah, that's right. All right, so now that's going to give me back an object that's going to have a render on it. I mean, that's all I really care about. I'm sure there's other stuff that's useful in there, but I don't care. And now I'm going to go ahead and say that my join layer dot renderer equal to renderer. Can't say that damn word. It's just, I've never been able to do it. Now I'm going to do map dot add join layer. Okay, so let's see if this works. Let me save this. I don't know how long it's going to take. And I'm afraid to open the console because it's probably going to show me an error. I should open the console, see if there's any errors. FRS results is not defined. FRS here we go. See? I should look at the console to find out if there's errors. Oh my goodness. All right, so let's see how fast this is going to take. Let's remove this. Oh, there was something popped up. There was an error. I missed it. Okay, we're going to do this too. We're going to go ahead and check this thing here. So my temp2 array, all right? Yeah. Okay, let's do it this way. So temp2. So for every time I iterate this, I want to log console.log temp2.length, just so you can kind of see that that array shrink as we iterate over this, right? There you go. See, so you can see the array is shrinking and shrinking. FRS spell capital L. But see that? So I'm able to cut the workload down as that function is doing its work. And bam, there we go. And there we go. Okay, so I'm going to zoom out one more, just so you can see what difference a zoom level makes. And let's wait for that to load. And as I'm sitting here, I'm just going to go ahead and talk nonsense because this is probably going to take a little bit. But okay, so man, you can see a big difference. Starting at 87,000 features now, whereas before we're starting with like 13,000. So that's the difference that one level makes. And I am kind of slowing it down a little bit by having the console log there. I think it's actually a little bit faster if you don't have any log or console statements happening here. But this is going to run. It's going to take a while. And this actually, you can see here, it blocks the UI, which is kind of what you don't want it to do, right? Which is unfortunate. However, I mean, if I were really wanting to do this inside of an application, I would do this work inside of a web worker. I would not do it in the browser like this, blocking anyway, because it's a lot. I would let it do this part, right? Creating the features and the graphics. So this bit would all happen inside of a worker right here. I would actually pretty much copy this and tweak it a little bit, let it run in the worker, and then let it push the features back to me and create my layer that way. But you can see there it worked. We've got our layer here with above and below. So ones that are light blue have 1,800 or more of these pollutant, possible pollutant points inside of them, and the ones that are darker have all the way down to none inside of them. It looks like maybe that one there, can't tell. My master's thesis for geography actually had to do with stuff like this: toxic release inventory sites and the environmental justice impacts in certain areas and stuff like that. So that's why I kind of gravitated toward this data set when I saw it. I thought it was pretty interesting to look at, right? So like if you were to break this up probably into like neighborhood areas, there's layers out there for like places, they call them, which are broken down parts. You break cities down into like neighborhoods, right? And they're typically are called like a places layer that you can work with. And those are kind of interesting to do. Stuff like, where would it be at? Let me see if I can find it here. The city of industry, which is, I believe it's this strip right here. Yeah, this strip right here. This is the city of industry right here. So we got our object ID. I don't have my count in the, I didn't add it to the pop-up template field infos. That's why. But yeah, so this is the city of industry here, and it definitely has a lot of those particular features. And that was where I kind of focused my my paper on. But yeah, there you go. So you, like I said, you can do a spatial join in a web app with the ArcGIS API for JavaScript. If you want to do something like this, right? You want to maintain the data in some way. It's going to take a little while, depending on how much data you have. And realistically, you can see here, I had like 85,000 points at this particular scale. So my point data set may not be close to what you want to work with. Maybe you're working with a couple of thousand points, 5,000, maybe even less than that. And you want to do these quick kind of analysis on the fly in your web app, and you could do that. I think if you had a few thousand points, 300 to 400 polygon features to work with, right? I think that's a doable scenario. When you get above that, it just kind of gets exponentially more work for the browser to do, and it's going to take a little longer to do. And again, it's a blocking function, right? Doing that iteration, everything like that. So I would definitely recommend that you look into doing custom workers for something like that and let that run in the background, and then get your result back, and then you're good to go. I think that is probably the best solution for something like this, right? And we use workers everywhere in the API. I mean, we use them like crazy. We're just worker nuts, man. So yeah, there you go. I just wanted to kind of quickly show that. You can I'll try and put this link in the description for this video after I'm done here. Let's put this back to the 12. And I hope that helps you out. Go ahead and try it out. I said, don't be afraid to try stuff like this. People tell me I do dumb stuff all the time. I don't care. It gets done. It's cool, right? And you get stuff like this. At least it's a solution you can try implementing yourself. So have fun. Thanks a lot. Oh yeah, don't forget to